welcome to my YouTube channel, IntelliJ Coding Lab. In this YouTube channel, I will be talking about the Java programming language in detail, and also the microservice architectures, different design patterns, and optimizations, and all that. So in this first video, I want to talk about the basics of Java, and we'll write a hello world, and also we'll talk about the basic data types available in Java so that we can encode the information using the Java data types. So first thing first, to be able to write programs in Java, we first need the Java runtime environment, and for that we need to first go to the Oracle site and download the JDK, which is the Java development kit that comes with the Java runtime environment. And once we set up that, we should be able to write our Java code and compile that Java code into Java bytecode and run that bytecode on Java runtime environment. So let's do that. And as I said, to be able to do that, I will go to my browser. You can see I'm in oracle.com/java, and here I can see the option to download JDK 20, which is the latest version, or JDK 17, which is the last stable version. So I'm going to go for JDK 17 for now because that's the most stable version, and you can see multiple options here. It could be Linux, Mac operating system, or Windows. I'm working on Mac, so I'm going to download the Mac operating system version of Java, but if you are on Windows or Linux, you can download the corresponding version for your machine. And on the product list here, you can see multiple options. You can see DMZ installer, or you can see the compressed archive. Also, based on the CPU architecture, either you can download the ARM64, that's one of the CPU architecture, or x64, that's another CPU architecture. Mine is 64-bit CPU, so I'm going to download the compressed version because I find that easy. But you can download installer, which is just click and it will set it up for you. So I will click on download, and you can see the JDK being downloaded. Now it's downloaded in my downloads, so I'm going to my terminal and go to my downloads folder, and if I ls, I can see JDK 17 macOS 64-bit tar file, right? So now I can extract that tar file, and for extraction I can use tar command and JDK 17. Once I extracted that tar file, now I need to set up. Now when I ls, I can see the unextracted version here, right? Now the next thing is I want to set up my Java home. I want to move my JDK to the recommended place in Mac operating system, which is library/java/java virtual machines. So I want to move it there. Okay, it's moved. I want to make sure that it has enough permissions. Right, I can see that file has been moved. I gave the enough permissions, and now I set up my Java home to point to library slash Java virtual machines slash ZDK contents home. So I set my Java home to the ZDK, and now if I do Java version, it should give me the Java 17.0.8. That's the one we just set up. So that's one way of setting up Java. The other way, as I mentioned, is you can actually just download the installer, and you can just do the clicks and it will set it up for you. Now once we set up the Java, let's write some code in Java and compile that code. So let me go to desktop UC labs. That's where we'll keep our code. Everything is empty here, so I'm going to create a directory and call this HelloWorld Bajai. Now let's go inside HelloWorld and let's create a file using vi command, which is the terminal editor. Let's call this hello world Java. And the reason I did Java is every file in Java has to be has to have the extension .java. Okay, so I create the file. Now I'm inside the file, and the basic building block of Java is what we call a class, and the class represents the real world objects. Because Java is the object-oriented language, everything in Java is represented or encoded as object, right? So for example, I want to build a software that transfers money from user A to user B, or any user, right? So if I want to encode that software in Java, I have to encode that in terms of the objects. There will be an object called sender, and there will be a receiver, right? Both are the objects, and I'm transferring the money, so money is another object. So everything is viewed in terms of the object in Java, and that makes it easy to solve the problem using object-oriented programming language. And the concept I just mentioned of the object is or can be encoded in Java using something called class, right? So in our case, we're just printing something, just writing hello world. So I'm going to call this class hello world Padai, and the class name has to match my file name. That's why I kept it the same. And then open curly braces and close curly braces. Everything I write will be within these curly braces. Then the objects in object-oriented programming or in Java have two characters. One is they have their properties, meaning the sender in our example who sends the money has their first name, their last name, They might have their address, their contact number. So those are the properties of the object, right? And the second thing the objects have is their behaviors. And in case of the money transfer software, what is the behavior of the sender? They send the money, right? And what is the behavior of the receiver? They receive the money, right? So those are the behaviors. So now let's encode those things in our example. The first thing I said is the objects have properties. Now, what is the property of the object we are building here? Right? We are, as we said, we want to print something. So the property could be the value it wants to print, right? I'm going to create a property. The value is going to print, and let's call it welcome to Upadhyay Coding Lab. And as you can see, I wrote string, that's a data type, value, that's a variable, I could give it any name, then equal sign, and then double quote, and the value we want to print, and then semicolon. So what's happening here is the value welcome to UC Lab is assigned to the variable value, and the semicolon represents that the statement is complete. This is all the statement. So this is the property of this class or this object. Now the another thing we mentioned in the behavior. What is the behavior of this object? We want to print something, right? And since this is the entry point for Java, actually Java expects a method or behavior on this particular class, and which is called main behavior or the main method. So I have to write a method which goes like this: public, because it needs to be accessed by Java and it has to be accessible, so it's called publicly accessible. Static, because Java needs the direct access to this behavior, so it's static. Void, void represents if this behavior is responding back something. We are just printing out something here, but also Java expects this particular behavior to always return or respond void, meaning nothing, and main. So main is the name of the behavior, and as you can see, I did curly braces open and close because everything, the behavior, the logic will go inside these curly braces. But the main method that we just wrote also expects the input arguments of type string array. So I did a string array and then arguments. We are not using those arguments now, but if I provide any input through my terminal, then I could have made use of those arguments variable. But now I'm not going to use that. So inside the main method, let's print something using Java library, which is system.out. Dot operator here is used to access the properties of the object or class, right? We talked about the properties here. So to access the property directly, I can do dot and the property, and dot again print ln, which is the behavior of out object, okay, meaning system.out will give me one object, and on that object I'm calling a behavior println, and the method expects the input, right? And input is, we want it to print something which is the value, and I ended that statement with semicolon again. Now one thing, my method here you can see is static, and my property also needs to be static, so I'm going to make that static as well. And this class also needs to be public, because as we said, this needs to be accessed by Java so that it can run this behavior. So this is our first hello world, pretty straightforward. I know there are a few things we talked about, like the object having properties and behaviors, which are the basic foundation of Java, and we'll talk about this more in coming lessons as well. So this is my Java code, and now I exit editor. Once we write the Java code, the next step is we need to compile the Java code. And to compile it, Java provides a javac terminal. Javac expects the source file that we want to compile. So we do javac and the file we just wrote, which is hello world upadhyay.java. Now we want to compile this code. It is done, right? Now if we do cd folder, we can see .class file now, which is the actual compiled bytecode. If I want to see the value inside that class file, I can do cat and hello world upadhyay.class. You can see the compile code here, which is the bytecode. And if you compare that with the code we wrote, hello world upadhyay.java, you can see the difference, right? This is the structured Java code where we have the class, curly braces, the property, and the main method, but that is turned into the Java bytecode. And this is what Java runtime will use to run our program. Now once it is compiled, I can run Java command, and I provided what class I want to run. So it's hello world upadsyay. If I run that, what do I get back? I get back welcome to UC lab, and that's what we printed in our code, right? So this ends our first program, which is pretty straightforward. We wrote the code, we compiled the code, and we executed the code using Java runtime. So this is how we can write code in Java language. Now the next step we are about to do is we take the same code, but instead of writing the code in our terminal, we can achieve the same thing using the IntelliJ IDEA editor. So let's do that. Now I can go to the browser and search for IntelliJ IDEA for Mac operating system, and I can get to the homepage of the IntelliJ IDEA. That's the most popular editor for Java these days, for quite a while now actually. So let's download that. It's a pretty big file. It's 1 gigabyte of file, so it's going to take a while to download. And once it is downloaded, we can, this is an installer, so we just can double click the file and be able to install it. So now I go to my downloads and I can see the IDEA installer. So I double click on it and drag to my application, and that should install my IntelliJ IDEA application. So I should be able to double click on it and start the IntelliJ IDEA. It is asking for permission. Awesome. Already installed it. Now we can create a new project. You can see new project option here, and we can give it a name. Let's give it a name, HelloWorld Upataya. That's the project name. Then location, you can select whichever location you want, but I'm selecting desktop UC Labs. Then it asks for the language. Obviously we are doing Java. There are multiple options like Kotlin, Groovy. Kotlin and Groovy are different languages, but they also compile their code into bytecode, and that can run on Java runtime environment. So that's why you will usually see people using Java along with Kotlin, Groovy, and even Scala. So I'll pick Java for the language. And the build system, I'm using Gradle. So Gradle is a Java build system that helps compile the large Java project and also help manage the project dependencies. So it's a pretty popular build tool. When you are building large software, you don't want to do manually everything. You want to use some build system like Gradle. The another popular one is Maven and JDK. I'm going to select the one that I have installed, and DSL, I'm going to pick Groovy. Add sample code, I don't need that. There are a bunch of advanced settings as well, and I'm just selecting the default values for that. So let's do create. The IntelliJ IDEA uses a lot of processing power, though you can hear the sound in the background already. Now you can see the Gradle build file. This is not very important for this lab, but you can see that the Gradle is setting up to say that it is using Java, and it is using some dependencies for the testing purpose, which are the unit test, and will not touch on this lab either. But basically, let's assume that everything that the Gradle is setting up is all we need. Okay, so and here you can see the structure set up by Gradle as well. You can see src main Java, and that's the standard folder structure that all the Java projects use, and will use the same. And in the src/main/java folder, let's create a new class and let's call it HelloWorld Padhai. Okay, when I enter, you can see that it created a class which is public by default, and it added curly braces as well. So inside that class now, we will have to write the code we wrote in the terminal, which was, if you remember, public because it needs to be accessed by Java runtime, static needs to be accessed by Java runtime directly, void, it doesn't return anything, and main, that's the name of the behavior or method, and it takes arguments, string array, let's just call it args, and open curly brace and close curly brace. And inside that method we wanted to print something, and before that we had a property of this class which is static string. We want to print the message equals to some value and semicolon, and the value was welcome to the Padhai coding lab, full stop. Okay, now inside the behavior, now research system. Now you can see the drop down here, which is a nice thing about the IntelliJ idea, that it gives us all the possibilities that has system word in it, right? I just typed in system, it shows me system, system color, system tray, all the different classes. But we only need system dot, and again when I do dot, it gives me all the properties of system class. The properties are out, error, in. It also gives me the methods, which are the behaviors of system class, which are gc, console, current time, etc. We need out property, so we need out, and then we need to print value, so we need to do dot print ln. We can see again IntelliJ idea giving us all the print ln methods varieties. So to be print ln, we want to print the message. So we provide a message, and that's all. We are ready to run the Hello World in the IntelliJ idea as well. I can right click on it. I can see the run option here. Click on run, and we can see it compiled for us. In the terminal we have to compile manually, but the Gradle will compile our code for us, and then it will run the main. We see the output that we expected to see, which is welcome to UC Lab. So that brings us to the end of our Hello World session, both in the terminal as well as in the editor. Now the next topic in Java is the data types. So we said that Java encodes every problem that we want to solve using the objects or the classes, right? But to represent the information in the real world, like the names of the people or the age of the people, the address of the people, we need to encode those information using the Java data types, and those are the basic block of the software development. So there are 4 basic data types. and let's go through all of them here. The first one is the integers, which represents the whole numbers, and the negative counting numbers. Right, so whole number could be 0, or the counting number 1, 2, 3, 4, and the negative counting number negative 10, negative 30. That's one data type, right? The another one could be we want to encode the fractional numbers like 1.5 or the gravitational acceleration 9.8, and those are called decimal numbers, and in Java called float or double. Then another data type is the Boolean, and that represents whether something is true or false. And the last data type is the character, and that represents the Unicode characters like the English alphabet, P, or the Spanish O, which is /U, and 0, 0, and FE, that represents the Spanish O. So these are the basic data types in Java, and let's go through each one of them. So let's write a main method again that takes the string array as args, and inside that let's define our first data type, integer. Java provides int keyword to represent the integers. So I have int, and let's say I want to define the items I purchased from Amazon. Okay, and let's say I purchased 20 items, so I'll define 20. Right, so I'm defining a variable items purchased and assigning value 20 to it. And by default, this is a positive number. And let's say out of those 20 items, 5 items were damaged. So int damaged items 5. Right? Now, just like in mathematics, I can do the operations like plus, minus, multiplication, or division. So let's say I want to calculate how many items are good, right? So I can do int good items equals items purchased minus damaged items. Right, that will give me the good items. Now I can print that value. Let's print good items, and it should give me 20 minus 5, 15. I run it, and we can see 15. One limitation with the Java int type is that it is a 32-bit data type, and what that means is the integer can be maximum of 32-bit, and 1 out of 32 bit is reserved for the plus or the minus sign. So the first one is reserved, which is the most significant bit, is reserved for plus or minus, and the rest 31 bit can be the actual value, right? So let's say if it's a positive number, then the first bit is 0 and all the 31 bit can be 1, right? So let's say the rest of the 32 bits are 1, right? So I got 6 bits here, 12, 18, 24, 30, and 31. And if we convert this value, this is going to be 2 to the power 31 minus 1. That's the highest value, positive value we can have. And the smallest negative value that we can have is 1, because 1 represents the negative number, and all the rest values could be 0. All the 31 bits can be 0, right? And that value is going to be 2 to the power 31, and obviously minus. So anything bigger than that or smaller than that cannot be held in integer data type. Let's see an example, right? I want to represent my YouTube views into a int data type. So my YouTube views equals, let's say I have 2 billion views, okay? 2 underscore 9 zeros, okay? That's happy. The underscore here represent semicolon in mathematics. So 2 billion can be stored. Let's try to see if we can store 2.1 billion. Yep, it's still happy. Let's say my views are 2.5 billion. Now it's not happy. It's red and complains that integer number too large. So we can say that the highest number it can hold is 2.1 billion. Well, that's the tentative. It's slightly more than that, and you can get that value actually with integer dot max value, and you can see the value is 2.1 billion, but it's 2.147483447. What is the solution for that? What if I want to store, what if my YouTube views is more than 2.1 billion? And that was actually the problem with the YouTube. When the view for the Gangnam Style video hit more than 2.1 billion, that actually broke the YouTube, because they were storing that information as the 32-bit integer. So if you want to hold bigger value, bigger whole number, then Java provides long, which can hold up to 64-bit. So if I want to store YouTube views in billions, then I can store, let's say, 5 billion in long type, and I have to encode it with L so that it knows the value is long data type. And the mathematical operations are just like in integers. I can do plus, minus, division, and multiplication. the maximum value for the long is 2 to the power 64 minus 1, and that is about 9 quintillion. And quintillion is 18 zeros. So let's say long YouTube views max could be 9,000 times 15 zeros. Okay, but if I want to store 10 quintillion, it will fail. Right? It says number too large. So now we did the integers and the long integers. Now let's say if we want to store the decimal numbers, which is values like 9.8, which is the gravitational acceleration. So Java has a float type, float acceleration equals to 9.8 f. So f is encoding the decimal numbers, and float can be 32-bit max, and out of 32-bit actually the first 1 bit is assigned for the sign, positive or negative, and the next 8 bits are assigned for the exponent, and the last 23 bits are assigned for the fraction value. And the maximum value for the float could be 300 on decillion. The max float can be 300 and E36. E36 is the scientific notation for saying 10 to the power of 36. So this is 300 on decillion. Right, if I want to store, let's say 390 on decillion, then it will complain. And to store bigger than 300 on decillion, we have a data type called double, and this is 64-bit data type. Let's say balance. My balance is too big. I have a lot of money. So if I want to store 390 on decillion, then I do 390 E36 10 to the power 36, then D. And D represents, this is a double data type. It can be small or capital T, doesn't matter. So that is the integers and the floats data types. Now another basic Java data type is the Boolean, which represents whether something is true or false. So it is a 1 bit, right? 1 for true and 0 for false. So let's say I want to encode whether it's raining today, right? So Boolean, which is a data type, is raining today, false. It has to be small letters, so that's how I encode the Boolean. If it's sunny today, Boolean is sunny today is true, and that's how I represent the true. Now the last basic data type is the character, which represents the 16-bit Unicode characters, and it is keyword char, char. People also pronounce char. I like to pronounce it char because it's for character, but however you want to pronounce it, go ahead. Character, let's say I want to encode the block that you live in, right? Because your complex might have different blocks. So block I live in equals to, it's a single quote, and the block P. Okay, but it could be P or small p, whatever it is. I can also use the Unicode characters like Spanish O, which is represented with /U because it's a Unicode, and 00 F3 for O. Right, so now I can try printing that. System.out.println and semicolon. I provide the value Spanish O, and if I run it, you can see it printed the Unicode character O. So that brings us to the end of the basic data types in Java, and we cover integers, long integers, float, double, and booleans, characters. So those are all the basic data types. The other data types in Java are called the reference data types, and the difference is that in the primitive data types like the integers, longs, doubles, floats, booleans, and characters, when we assign the value, right? So here block I live in is P. When I assign the value to a variable, the variable actually points to the value, right? When I give the variable to somebody else, they will actually get the value itself. But in the reference type, if I give you the variable, I'm not giving you the value, I'm giving you the pointer to the value, right? So that's what the reference type is. Instead of giving you the exact value, I'm giving you the reference or the pointer to the value. And one of the example is a string data type. And a string is basically an array of the characters we just learned here, right? In the character, we can only hold one character, but if there is a bunch of characters like the text messages or the paragraphs we want to encode, then we want to use string data type. So string name equals Agile Coding Lab, right? You can see I can use bunch of characters here inside the double quote. If it was a character, you use single quote. And just like the primitive data types, the string data type also has some operations. Let's say I want to add on name. So I can do name plus, I want to add a space first, and then just say I want to add the date, 2023, right? Then I want to assign that to a new variable, updated name. So you can see that I'm using name variable and adding some more text here. Now let me print that value. Okay, so I'm printing updated name. So when I run it, it should print Padai coding lab. You can see hyphen because that's what we added, and 2023. There can be more operations, like turn every character in the string to uppercase, or I can turn everything in the string to lowercase. I can split the string by space character, so I can do a bunch of operations on a string. Let's say I want to turn everything in uppercase, okay, and I will store this in uppercase name, and let me print that. So it should print everything in uppercase. Yep, everything is in uppercase. So that brings us to the end of the reference types. Now let's do one exercise to write a software through which you can make a payment to any e-commerce. Right, once you purchase an item, let's say you want to make a payment to your merchant. So let's say on Amazon.com, you're making a purchase of, let's say, ramen noodles. Now you want to make a payment for that. So we'll build a software that takes your account information, the item you are purchasing, the amount you're paying, and the merchant that you are paying for. So we need those four information. So let's create a new project. Let's call it merchant payment software, and it's Java Gradle. We use JDK 17. Let's just call it com.merchant payment. Okay, cool. It's creating a project for me. You can see it's building a model at the bottom. IntelliJ could be slow sometimes while indexing the dependencies. Now it created src main/java. So in Java folder, let's create a Java class and call it merchant payment software. So as we discussed before, in Java, since it is an object-oriented language, it has the properties and it has the behaviors. So what are the properties of the software? Right, so we have as we said, we have the buyer, right, because we are buying a product and making a payment. So we have a buyer, we buy a product, we make a payment of certain amount. So amount is in, could be a decimal number, so let's call it a float amount to pay, and then we are paying to somebody, to a merchant, so, or a seller. So we have a seller information. Sounds good. Now as an entry point of every Java project, we need a main method. So we write public static void main, curly braces open and close, and in the main method it takes an argument which is an array of string and arguments. So inside the main method, now we need to ask for the input to the user, saying, hey, who is the buyer? Okay, so let's say I print a message which is done through system.out, which is a way to print on the terminal, and print ln. So the first thing I'm going to ask, or the software will ask, is enter the buyer's name. Enter buyer's name. Okay, and right after that we need to input the buyer's name, right? But to be able to do that, just like how system.out printed something on the terminal, we need a way to extract the information that is being written by the user, and for that we need something called a scanner, and it comes from Java util. So I need to import java.util.scanner. So when I do the import, it will actually load that class for me into my project. So now I can say create an instance of a scanner. Okay, so I'll call it input scanner equals to, as you know, instantiation in Java happens through new and scanner, but the scanner takes an argument of the system.in. Actually, you can see that here, right? When I don't provide anything, it complains that it cannot resolve the constructor. The scanner is called constructor. So here there is an error, right? There are multiple ways I can call the scanner, and so you can see that I need to provide the input string, right? So I will provide that through system dot in, and you can see its type is input string. Okay, cool, it's happy now. So now I ask the user to input their name because they are the buyers. Now I extract what the user writes in, which is through input scanner dot next. Okay, and I need to put that value, whatever I extract through the terminal, into the buyer variable at the top, right? So I assign that to buyer. Now it's not happy because we are in static method here. You can see that static void, but this string buyer property or variable is not static, and you can also see the error here, right? IntelliJ tells you in your face that non-static field buyer cannot be referenced from a static context, right? Because this is a static context and this is non-static context. So I'm going to make this static. Okay, now it's happy. Then, okay, it will ask the buyer's name. Buyer will write in their name. Then we need to ask again, or the software needs to ask again their product they are buying. So system.out print ln. So we can see here system.out for writing something and system.in or extracting or reading something. So system.out.println string enter product you are buying. Okay, now it will print enter product you are buying, and you will type in, let's say, ramen noodles. So that needs to be extracted with input scanner dot next and should be assigned to product. And this is not happy because same thing as last time, that we are accessing non-static variable from a static context. So I'm going to make these static as well. Then again, the software will ask to enter the amount for the product or amount that you are paying. So enter the amount you are paying. Okay, so just like before, you will type in some amount, and then input scanner will read. Since this is a float number, we have a next float method that will extract the float amount you type in, and we need to assign that to amount variable. Okay, so amount equals to input scanner dot next float. This is not happy because we are accessing non-static variable from static context, so I made this static as well. And the last information that the software will ask for is who am I paying this amount. So system.out.println, and the software will ask enter the merchant you are paying to. Okay, so now you will type in something, so the software will extract that using input scanner dot next, because this is a string value, and this needs to be assigned to seller that we defined at line number 8 here. And this is not happy for the same reason that we are accessing a non-static variable from a static method here. Okay, so that means both need to be static. I define seller as static as well. Cool. So with this, we wrote a software that takes the inputs for the buyer's name, the product you are buying, amount you want to pay, and who you want to pay. Once all of that is provided by you, now we want the software to print all of that information out to you, saying that your name, let's say Richard Finman, paid amount 10 or $35.21 for the product ramen noodle to merchant ramen LLC. I don't know, whatever is their company. So let's do that. System.out.println. So we want to print a message that says buyer, right? Buyer space made a payment of plus, I'm concatenating the string, made a payment of amount. Okay, that will replace the value with the amount for a product plus the product name, which is in the variable product, plus to the merchant, and plus the seller name. Okay, you can see the value is too long, so I'm going to send this to the next line. The practice is that you don't want to write a value or a variable, any statement that is too long, too horizontal, because you want to read that in one screen, right? So IntelliJ by default has a line here. You can see that 120 line, meaning that you can have 120 characters in one line. But some companies or some engineers also follow a practice of 100 lines. So if your statement crosses 100 lines, you will write next of the information into the next line. Okay, so we prepare the message. Now we want to print that message. So the message will say that your name, let's say you are Richard Finman. Richard Finman made a payment of $35.21 for a product, ramen noodles, to the merchant Ramen Noodles LLC. Okay, now I'm going to run this application by right clicking, and there is an option run, so click on that. Now you can see it's asking for the buyer's name. I'm providing Richard, product name, enter the product you are buying. I'm buying ramen noodles. Enter the amount you are paying. I'm paying $35.21, and enter the merchant you are paying to. It's going to be ramen. Okay, when I enter that, you can see it printed the output message that we wanted it to print. Richard made a payment of $35.21 for a product ramen to the merchant ramen. And that's it. We wrote a very basic software that takes an input from you and then prints out that message, which is awesome. Now you just need to build on top of it to write more complex software. And it's the same idea actually. So this is on the terminal, but now it's the same idea when you build a desktop application or the web application. We'll get to there later, because we'll actually in real world be building either desktop software or the web software, like the web inputs, where you have enter buyer's name option, and then on the right side you'll have the input box, like the login box of the Amazon.com, right? There is a login, username and password. So it's a similar fashion we can build this software using HTML and Java in the backend. So we'll get there in future. But with this, we conclude our first session of writing Hello World, learning some variables, assigning values to the variables, different primitive Java types and reference types, and we wrote a little software as well that takes an input and prints out the message. I hope you learned something from this session. If there are any questions, please make a comment. I'm here to help you learn Java, so let's go.